Hello friends, we have already completed one portion of trigonometry and that is trigonometric function. We have discussed regarding the six function sine, cos, tan, cot, sec and cosec theta. Now on the basis of the same concept trigonometry, we are going to start a new chapter, chapter number 9, that is application of trigonometry. Now we have to use the formula of chapter number 8, that is relation between sine, cos, tan, sec, cosec and sec, as well as you should also remember the value of the different function for different value of theta. That is, you know one table, the sine theta is equal to 1 by 2, sine 30 is equal to 1 by 2, sine 45 is equal to 1 upon root 2, like this. Well, so here in this chapter there are only two concepts and you have to use this concept in different examples. The name of the first concept is angle of elevation and the name of the second concept is angle of depression. So first of all, let us try to understand these two concepts and then we will solve some example. Well, the first concept is angle of elevation. So when a person observes in upward direction, you have to use concept of angle of elevation. When a person observes in downward direction, then you have to use angle of depression. So what is angle of elevation? So the angle formed by the line of sight. You can say line of vision. You can say ray of vision with the horizontal line when it is observed, when it is above the horizontal level. That is the case when we raise our head to look at the object. So when you look to the object, when the object is in the upward direction, you have to use angle of elevation. For example, one triangle is given to you, A, B and C. For example, AB is a tower. A person C stands on a road. When a person observes the top of the tower, and that's why this is known as ray of vision. Ray of vision. You can say ray of sight. And this is known as horizontal ray passes from the eye of an observer. Because AB is a tower, A is top of a tower, C is a person, so BC is nothing but is a horizontal ray passing from the eye of an observer. And similarly, AC is known as ray of sight or you can say ray of vision. So according to this definition, the angle between ray of vision and horizontal line, so this angle, we use one word theta, is known as angle of elevation. So again, when a person observed in upward direction, then the angle between ray of vision and horizontal ray passes from the eye of an observer, and this angle is known as angle of elevation. So this trigonometry used to find out the height of the tower or to distance between two vehicles situated on a road. So, and that's why the name of this chapter is application of trigonometry. Well, the second concept of this chapter is the angle of depression. When a person observes in downward direction, one has to use the concept of angle of depression. For example, AB is a tower. C is a car situated on a road. So a person standing on a tower observing the car on the road. So this is known as ray of vision. Ray of vision, or you can say ray of sight. And a person is on the top of the tower, and that's why this is known as horizontal ray passes from the eye of an observer. So this angle is known as angle of depression. Now, the angle formed between ray of vision and the ray passing from the eye of an observer is known as angle of depression, and that is the case when we observe in the downward direction. So when you observe in the upward direction, you have to use concept of angle of elevation. When a person observing downward direction, one has to use a concept of angle of depression. So angle of depression means a person observing downward direction. Angle of elevation means when a person observing upward direction. In most of all the example, you have to use these two concepts. If you are perfect in these two concepts, you can solve any example of this chapter. So let us start exercise 9.1. First example, very simple example. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of the vertical tower, that is pole, to the ground. Find height of the pole. If the angle made by the rope with ground is 30 degrees. Well, so a circus artist climbing a 20-meter long rope, and this rope is tightly stretched and tied from the top of the vertical tower. So AB is a tower. AB is a tower. The rope is tied, stretched tightly with the top of the tower, vertical tower, to the ground. This is ground. So BC is ground, AB is a pole, and AC is a rope. Here 20-meter long rope. So if you consider this is right angle triangle, the length of the hypotenuse is given to you, that is 20 meter. Find the height of the tower. Here you have to find out the height of the tower. So assume, suppose height of the tower is h. Find the height of the pole or tower. If the angle made by the rope with the ground, the angle is given to you, that is 30. Now you have to use first formula of chapter number 8. That is, sine is equal to opposite upon hypotenuse. Cos is equal to adjacent upon hypotenuse. Similarly, tan is equal to opposite upon adjacent. Opposite upon adjacent. So here 30 degrees given to you. So either you can take sine 30, cos 30 or tan 30. But the value of hypotenuse is given to you. And opposite side means AB. The opposite side of 30 degrees AB and hypotenuse is given to you. So we can use sine 30. So when you use sine 30 means opposite upon hypotenuse, means AB upon AC. Sine 30 means 1 by 2. AB means H and AC means 20. So you can say 2H is equal to 20, and that's why H is equal to 10. So the height of the pole, or you can say tower, is 10 meters. So on the basis of the length given, you have to select either sine, cos or tan. For example, here opposite side is given to you and hypotenuse is given to you, and that's why the formula which concern with opposite and hypotenuse, and that's why it is sine. So we have used sine 30. Very simple example. How to find out the value height of the pole? Well, now second example. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Let us see this in the figure. For example, AC is a tree. AC is a tree. A tree breaks due to storm and broken part bends. So due to storm it breaks from the point B. So this broken part bends. So this BC bends and touches to the ground, and that's why you can say the length of BC is equal to AD. So broken part bends so that the top of the tree touches the ground, making an angle 30 degrees. So here you have to write 30 degrees. So this BC is known as broken part of the tree. Due to this stroke, it breaks and it touches the ground. So the length of BC is equal to length of BD. If you consider ABD as a right angle triangle, BD is known as hypotenuse. Well, this angle is 30 degrees. The distance between the foot of the tree, so this is the foot of the tree. Foot of the tree, A. Foot of the tree to the top, where the top touches the ground, and here the top touches the ground. So the value of AD is equal to 8 meters. Find the height of the tree. Here you have to find out the height of the tree. So your aim is, we have to find out the value of AC. Now here you have to take this triangle. So in triangle BAD, measure angle A is equal to 90, AC is equal to 3. You can also say BC is equal to BD, because BC is nothing but the broken part of the tree and is equal to BD. And measure angle ADB is equal to 30 degree, and you know AD is equal to 8 meters. Now you have to find out the height of the tree. The height of the tree means what? AC. So you can divide AC into two parts, AB and BC. So let us find out AB. So here AB means opposite side of the 30 degree, and AD is adjacent side of the 30 degree. So you can use tan 30 degree. So let us use tan D. So tan D is equal to AB upon AD upon AB, because tan means opposite upon adjacent. So tan D is equal to AB upon AD. So tan D means tan 30 is equal to AB upon 8. You know the value of tan 30 means 1 upon root 3. So 1 upon root 3 is equal to AB upon 8. So you can say root 3AB is equal to 8. Therefore AB is equal to 8 upon root 3. So here adjacent side is given to you, opposite side you have to find out, and that's why we have select tan 30. So by using tan 30 means tan D, we got value of AB, that is 8 upon under root 3. Now similarly here you have to find out CB, but BC is equal to BD. So here you have to use hypotenuse, and what is given to you? Adjacent side is given, hypotenuse you have to find out. So here you can adjacent upon hypotenuse means cos. So you can use cos D. So cos D is equal to adjacent upon hypotenuse. Adjacent means AD upon hypotenuse means BD. So cos 30 is equal to 8 upon BD. Value of cos 30 is equal to under root 3 by 2 is equal to 8 upon BD. So root 3 BD is equal to 8 to the 16. So BD is equal to 60 upon root 3. Now your aim is to find out the value of AC. Now AC means height of the tree is equal to AB plus BC. AB plus BC. But BC is equal to BD. So AB plus BD. AB, the value of AB is 8 upon root 3 plus value of BD is equal to 16 upon root 3, and that's why you can write 8 plus 16 means 24 by root 3. You can say 8 3 is 24 by root 3. You can say root 3 is 3, and the final answer is 8 root 3. So the height of the tree AC is equal to 8 root 3. Very important example. A tree breaks due to storm. The broken part bends so that the top of the tree touches the ground, forming an angle 30 degree, and the distance between the foot of the tree and the tree touches, that is known as 8 meter. Then find out the height of the tree. Here you have to consider BC is equal to BD. So BD is nothing but the broken part of the tree, and the broken part of the tree is equal to BC, and that's why BC is equal to BD. So first of all we use tan 30 and then cos 30. By using tan 30 you get value of AB. By using cos 30 you get value of BD, that is BC. By adding these two you can easily find out the height of the tree, and that is AC. So today we have understood main two concepts, the angle of elevation as well as angle of depression. When you observe in downward direction you have to use angle of depression, and when we see in the upward direction then you have to use angle of elevation. So the angle between ray of vision and horizontal line passes from the eye of an observer, that is known as angle of elevation. When you observe in downward direction, then the angle between the horizontal line passing from the eye of the observer and ray of vision is known as angle of depression. And we have solved example number 9.1 as well as 9.2. Here the rope is given to you, that is 20 meter. The angle between the rope and the ground is given to 30 degree. Here you have to find out the opposite side of 30 degree, and that's why we have used sin 30. Similarly here we have used tan 30 because you have to find out the height of the tree and adjacent side is given to you. Then we have used cos 30 and we have already found out the value of the AC. So in next period we will start another examples of chapter number 9, exercise number 9.1. Thank you friends. Thank you.